Until now, California's greatest threat was thought to come from its faults, not from a hidden volcano. But beneath the surface, strange seismic swarms, unexplained heat, and ground bulges have experts warning that a silent volcano might be waking up. If it erupts, entire communities could be at risk. So how real is this threat, and what is the science saying that the headlines aren't? The true epicenter of the seismic swarm lies far from California's cities and highways. Instead, the activity is concentrated beneath the Northeast Pacific, anchored to a submarine volcano known as axial seamount, underwater. Its coordinates are 45.95 degrees north latitude, 130 degrees west longitude, placing it roughly 300 miles off the Oregon coast and nearly 700 miles northwest of San Francisco. Sitting 1 mile beneath the ocean surface, Axial rises 3,600 feet above the surrounding seafloor, forming a caldera that stretches about 3 by 8 kilometers across the Juan de Fuca Ridge. Recent swarms have not crept toward the continental shelf or the California coastline. Instead, every significant earthquake in the 2025 sequence has clustered deep within Axial's central caldera, at depths ranging from 1,400 to 1,750 meters below sea level. Over 1,000 micro-earthquakes have rattled this submerged landscape each day, tracked in real time by the Ocean Observatory's Initiative Regional Cabled Array, one of the most advanced underwater monitoring systems in existence. This network, together with independent catalogs from IRIS and NOAA, leaves little doubt about the swarm's offshore location. Bathymetric maps and satellite geodesy confirm the swarm's tight grouping. There is no evidence of seismic migration toward the U.S. coastline, and no shallow activity encroaching on the continental shelf. The entire event remains locked within the boundaries of the submarine volcano, far removed from any onshore hazard zone. Eruptions at axial seamount have been documented in 1998, 2011, and 2015, with scientists now projecting another eruption by the end of 2025. The volcano's repeat activity, combined with its remote setting, has made it a natural laboratory for studying underwater volcanic processes. As Oregon State University volcanologist Bill Chadwick explains, Axial is uniquely situated. It is both highly active and well instrumented, providing a rare window into the dynamics of submarine eruptions. Despite headlines suggesting a threat to California, the scientific record is clear. The seismic swarm's epicenter is not hidden beneath California's valleys or mountains, but anchored deep offshore, where the ocean and the Juan de Fuca Ridge conceal one of the world's most closely watched volcanoes. The real story begins here, far beneath the waves, where sensors capture every tremor and every sign of change. A constant stream of data flows from the ocean floor, relayed through the regional cabled array's fiber optic network. This underwater grid, stretching hundreds of kilometers across the Juan de Fuca Ridge, is wired directly into axial seamount's caldera. Thousands of sensors, seismometers, pressure gauges, hydrophones record every tremor, every shift in temperature, every subtle rise of the sea floor. Data pulses through the cable in real time, feeding directly to laboratories in Oregon, Washington, and beyond. Researchers can watch the swarm unfold second by second, with micro-earthquakes logged, cataloged, and mapped as soon as they happen. Unlike older volcano networks that rely on scattered land-based stations, the cabled array sits just meters above the active faults and vent fields. Its seismometers capture even the smallest events, often too faint to register on distant land networks. Every microquake is assigned a time, a depth, and a location, building a living map of magma movement beneath the caldera. The raw event stream is cross-checked against independent catalogs from IRIS and NOAA, ensuring that no anomaly goes unnoticed or unverified. Pressure sensors anchored to the seafloor measure inflation with millimeter precision. As magma rises, the ground swells upward, sometimes by as much as 25 centimeters in a single year. These measurements are not estimates or models, but direct physical records, updated continuously and accessible to researchers worldwide. The cabled array's live feed eliminates guesswork, allowing volcanologists to distinguish genuine unrest from background noise. Chadwick and his team rely on this data to refine their eruption forecasts. In 2015, the cabled array caught the first tremors of that year's eruption, providing a play-by-play account as the caldera floor cracked and vented lava. The current swarm is tracked with even greater clarity. With over 1,000 events per day, scientists can now pinpoint which segments of the rift are opening, which faults are slipping, and how quickly magma is intruding. The reliability of this real-time monitoring has transformed axial seamount into a testbed for eruption prediction. Each data stream, seismic, pressure, temperature, serves as a check on the others. When all three signal a change, confidence in the forecast rises. But even with this dense network, researchers compare their seafloor findings with satellite and remote sensing tools, seeking outside confirmation. The next step is to match these live feeds with signals from above, building a comprehensive picture of volcanic unrest that spans from the ocean floor to the upper atmosphere. Satellites orbiting hundreds of miles above the Pacific scan the ocean's surface day and night, capturing tiny shifts in the ground that would be invisible to the naked eye. Interferometric synthetic aperture radar (INSAR) is the main tool for this job. By comparing microwave radar images taken days or weeks apart, INSAR can detect ground movement as small as a few millimeters. At axial seamount, Area's processed interferograms reveal broad concentric bands centered on the caldera. Each fringe represents several centimeters of uplift. The data show that since mid-2024, the seafloor has risen by as much as 25 centimeters per year, matching the inflation rates recorded before the 2011 and 2015 eruptions. Precision. On land, Global Positioning System stations, GPS, anchored in solid rock provide another line of evidence. These receivers track their positions with sub-centimeter precision, logging every vertical and horizontal nudge. Offshore, the challenge is greater, but the regional cabled array includes pressure sensors and GPS-equipped buoys that can track the seafloor's slow rise. When magma intrudes beneath the volcano, the swelling is not a guess, it's a direct measurement, confirmed by both satellite and ground-based systems. Direct thermal imaging from MODIS and VIRs, two satellite sensors, adds a third layer of surveillance. These instruments detect infrared radiation, registering surface temperatures across the globe. For volcanoes above water, a persistent hotspot, typically at least 2 degrees Celsius above background, sustained for more than 48 hours, can signal new magma at shallow depth or active venting. For axial seamount, the ocean's depth means most eruptions never produce a detectable surface heat anomaly, but on land, these thermal pixels are an early warning sign. Hotspot. Each method has its strengths and blind spots. INSAR excels at wide area deformation, but heavy vegetation or water can obscure the signal. GPS provides continuous ground truth readings, but is limited by station placement and equipment reliability. Thermal satellites offer global coverage, but their pixel size, sometimes a kilometer wide, can miss small or diffuse sources. Scientists rely on cross-checks. When deformation and heat line up, confidence in the signal grows. When one system disagrees, the search for errors or alternative explanations begins. Cross-checks. Thresholds matter. For California's volcanoes, the United States Geological Survey (USGS) considers uplift above 1 centimeter per year or a thermal anomaly persisting over 48 hours as grounds for closer scrutiny. At axial, the current inflation is an order of magnitude above those cutoffs. These quantitative benchmarks help separate background noise from real unrest, guiding both scientific attention and public advisories. ARIA's processed products, GPS time series, and thermal anomaly stacks form the backbone of this evidence, allowing volcanologists to spot the difference between routine ground motion and the unmistakable signs of a volcano reawakening. Backbone. The California Volcano Observatory, known as CalVO, issues weekly bulletins tracking every monitored volcanic center across the state. Their November 2025 update lists 15 major volcanoes under continuous surveillance from Mount Shasta and Lassen in the north, through Medicine Lake in the Long Valley Caldera, to the Salton Buttes near the Mexican border. Each system is ranked for eruption potential and threat to nearby communities. Yet in the latest reports, alert levels for every California volcano remain at green, normal background activity. Long Valley Caldera, with its 17 by 32 kilometer footprint and a history of major eruptions, shows only minor earthquake swarms and steady low-level gas emissions. No new uplift, no unusual thermal signals, and no change in the deep magma body that sits kilometers below the surface. Mammoth Mountain, famous for its past swarms and persistent carbon dioxide leaks, is quiet. Mono Inyo craters, Medicine Lake, Clear Lake, and the Salton Buttes all present the same pattern. Routine seismicity, stable ground, and no evidence of new magmatic intrusion. Satellite data from area and ground-based GPS time series confirm these findings. No volcano in California is rising or swelling at rates above the 1 centimeter per year threshold that would trigger closer scrutiny. MODIS and VOLCANO thermal imagery, reviewed daily by Calvo scientists, show no persistent hotspots or nighttime anomalies at any monitored center. The only thermal activity appears at the geysers, a geothermal field near Clear Lake, where power plants tap the Earth's heat, but this is a known non-volcanic source. USGS bulletins emphasize that background fluctuations are common in California's volcanic systems. Small earthquakes, minor ground shifts, and seasonal changes in gas output all fall within the range of normal behavior. For a volcano to be considered restless, there must be a sustained multi-sensor signal, coherent uplift, rising temperatures, escalating seismicity, or visible gas plumes. None of these criteria are met anywhere in the state as of late 2025. The official record is clear. Despite viral claims and speculative headlines, CalVO data show no evidence that any California volcano is awakening. Every system remains at baseline, with no indication of impending unrest. The focus of scientific attention, and any real hazard, lies far from California's valleys and peaks. The verdict from the observatory is decisive. California's volcanoes are quiet, and the alert level stands unchanged. Long Valley Caldera stands as a stark reminder of the reach and complexity of volcanic hazards in California. At over 17 kilometers wide and 32 kilometers long, its footprint alone places entire communities, power corridors, and transportation routes within potential impact zones. Hazard models built by the USGS map out a spectrum of threats: ashfall, pyroclastic density currents, and lahars, each with its own reach and consequences for people and infrastructure. Ash is often the most far-reaching hazard. Even a moderate eruption at Long Valley could send fine volcanic ash drifting eastward, blanketing highways like US Highway 395, closing Mammoth Yosemite Airport, and threatening air travel across the Sierra Corridor. Trace amounts of ash can reach hundreds of kilometers downwind, disrupting visibility, damaging engines, and contaminating water supplies. Larger eruptions could carry ash as far as Nevada's highways or, with the right winds, even reach the Central Valley. Pyroclastic density currents, fast-moving surges of hot gas and volcanic debris, pose a more immediate danger. Simulations show these flows can travel up to 20 kilometers from vent areas, sweeping through the caldera and threatening the outskirts of Mammoth Lakes. Infrastructure such as the region's geothermal plant and high-voltage transmission lines, critical for both local power and the Los Angeles grid, lie within plausible run-out zones. In some scenarios, these currents could cross major evacuation routes before warnings reach all residents. Lahars are volcanic mudflows that follow river valleys and low-lying terrain, gathering speed and volume as they move downstream. At Long Valley, modeled lahar pathways trace the Owens River and Hot Creek, placing bridges, roads, and water pipelines at risk. A single lahar could sever the Owens Valley Water Project, disrupt Crowley Lake Dam, and isolate communities south of Mammoth. Similar hazards at Mount Shasta threaten Interstate 5, rail lines, and water infrastructure as lahars funnel down the Sacramento and Shasta River valleys. These models are not just theoretical. They draw on historical runouts, wind records, and modern simulations to map out where ash, pyroclastic flows, and lahars would likely travel. The overlap with critical infrastructure, including highways, power lines, dams, and population centers, means that even a localized eruption could ripple far beyond the caldera rim, disrupting daily life for thousands and complicating emergency response. For planners and residents alike, understanding these hazard zones is the first step in preparing for the unpredictable power of California's volcanic systems. County emergency managers across California emphasize that preparedness begins long before any eruption warning is issued. Residents living near volcanic hazard zones are urged to sign up for local alert systems, such as the County Office of Emergency Services notifications, which provide real-time updates on evacuation orders, road closures, and changing conditions. Most counties now offer text alerts, automated phone calls, and email notifications. Registration takes only a few minutes through official county websites or the statewide Cal Alerts portal. Emergency planning goes beyond signing up for alerts. The California Office of Emergency Services recommends every household within a volcanic impact zone assemble a 72-hour emergency kit. Core items include 1 gallon of water per person per day, non-perishable food, a flashlight with extra batteries, an N95 mask for ash protection, sturdy shoes, and copies of essential documents. For families with children, pets, or medical needs, extra supplies should be packed in advance. Portable radios tuned to NOAA weather radio or local emergency frequencies can provide updates when cell service is down. Evacuation maps and shelter locations are available on County Office of Emergency Services websites, and officials encourage residents to review routes ahead of time. In volcanic emergencies, roads may close quickly due to ash, debris, or lahars. Knowing alternate exits is essential. Schools, hospitals, and care facilities in hazard zones conduct regular drills coordinated by county emergency planners. Community meetings and preparedness workshops are held throughout the year, often in partnership with the California Office of Emergency Services and the United States Geological Survey Volcano Hazards Program. For ongoing updates, the United States Geological Survey Volcano Hazards Program website offers real-time status reports, monitoring data, and educational resources for each monitored volcano. The European Mediterranean Seismological Center, EMSC, and Volcano Discovery provide independent seismic event maps and field reports. Trusted information from these sources helps residents distinguish between verified scientific updates and rumors circulating on social media. Preparedness is not just a checklist. It is a mindset shared by emergency planners, scientists, and communities alike. By staying informed, assembling supplies, and knowing evacuation procedures, residents put themselves in the best possible position to respond to any volcanic event, no matter how unlikely it may seem today. Over 1,000 earthquakes per day were recorded at axial seamount during the recent swarm, as confirmed by the cabled array and independent seismic catalogs. Despite viral claims, no U.S. Geological Survey, California Volcano Observatory Bulletin has identified any California volcano as awakening in 2025. Satellite tools like INSAR and thermal sensors show all major centers, including Long Valley and Mount Shasta, remain at baseline activity. Yet the history of rapid change at sites like Axial, which erupted in 1998, 2011, and 2015, shows that volcanic systems can shift unexpectedly. What remains unknown is whether subtle precursors are always detectable with current technology. Official reports confirm no imminent threat in California, but the region's volcanic risk is real and ongoing. As scientists track every signal, the public's best defense is to stay informed through official channels. According to the U.S. Geological Survey, vigilance and preparation, not panic, are the keys to living safely in volcanic country.